Let's check for you. So I am going from where to where? I am going from A to B. Therefore, you will be writing potential at B minus potential at A, and the potential at A is equal to 0. Okay, this is equal to what? Okay, so you are going from the negative to the positive terminal. So plus 1. Now you are going across the 2 ohm resistor. Okay, and what about the direction of the current? Well, 2 ampere current is going here like this. 1 ampere current is being depicted here. You are going from A to B. Okay, now you have to understand that whether it's VA minus VB or it's VB minus VA. Think about this. Okay, so right now it is saying that find the value of the potential difference between the point between A and B. Okay, so let us check that between A and B, that means I am going from A to B. So let's say that I am going from A to B. So if I am going to A to B, can I say that actually my value of potential is VB minus VA? Right, it's VB minus VA. I hope you are getting this. So it's VB minus VA. If I have taken a path like this, can I say that this is basically a closed loop? What do you think? Is this a closed loop? No, it's not a closed loop. Therefore, I have not written that the summation of potential difference is equal to 0. So what I will write instead? Just put the values. Okay, simply write the value. What is the value of the potential between the point A and the B? So when I am calculating it by going from A to B, this is my path. So first 3 ampere current is going from the positive to negative terminal, therefore minus 9. Then it is going in the same direction as that of the current to the resistor 1 ohm. So minus 1 into 3. Again from negative to positive, that is 8. Again in the same way, minus 1, it's 3, right? So it's 3 into 2. Okay, now you are going from positive to negative of 7, so minus 7. What is the value here? Minus 9, minus 9, minus 3, minus 8, minus 6, minus 7. So summing this up, this will give me a value of minus 33 volt. So what is the value of the potential difference between the point A and B, between A and B? So if it's VB minus VA, that is minus 33. Okay, and if the question is asking VA minus VB, that is 33 volt. If nothing is given, then go with minus 33. And if the question specifically gives the equation, then take it appropriately. Okay, so I hope you understood this. Okay, was there any doubt, any confusion till this part, guys? Okay, I hope that there is no confusion over there. Okay, let me take few more questions for you. Okay, the question is the potential difference. Okay, here it's given VA minus VB between A and B in figure is, between A and B in the given figure is how much? So the question is something like this. Okay, this is VB, this is VA, this is a 2 ohm, this is a 3 volt, and this is a 1 ohm. Fine, calculate the value here. And yeah, there is one current going here. The value of the current is mentioned to here as 2 ampere. So you are having all the values. Now find the value of the potential difference VA minus VB. Okay, if the question is asking me VA minus VB, that means I am going from B to A. So let us go from B to A like this. So when I am going here, I found that the current is, I am opposite to the direction of the current. So the current 2 into 1 with a positive symbol as I am going against. Now you are going from the negative to the positive terminal, therefore plus 3. Again you are going against the current, so plus 2 into 2, that is equal to the potential difference here. So that is 2 plus 3 plus 4, that is equal to how much? That is equal to 9 volt. The correct answer to this question is 9 volt. Okay, I hope it's clear. Perfect. Have you seen that how speed you are able to solve it now? Okay, keep on doing the question. The next question is, in the circuit shown, if potential at A is taken to be 0, the potential at B is, the potential at B is how much? Okay, so it is giving a relative term here that the value of the potential at A is given as 0. I will be giving you a good method to do this question in the shortest moment of time. The diagram for this circuit is something like this. Okay, So it is given to you in this form. Okay, what is S given to you? So you are given the direction of the current as well in the circuit. This is 1 ampere and this is your 2 ampere. Okay, I think the question is not hard at all. This is your 2, this is your 2 volt, this is your 2 this is your 2 ohm here. Okay, okay, and let's say that 1 ampere over here, and let's say that the value of this is equal to 1 volt. Okay, what's more interesting is that the question doesn't give me the value here of the remaining two resistances. Let's say that this is R1 and this is R2. Okay, this was more interesting. Now if this is mentioned as a point A, this is mentioned as a point B, this is your point C and this is your point D. Now can you think of an idea of how to solve this question? In between resistances are also not given me. How to do this? Just think, okay? Okay, so I hope you have at least tried this. Basically the question asked me the value of the value between the part A and B. It is said that assume that here the value of the potential is 0. So basically the rule says that if you take the potential around a loop, that is equal to 0. What if I don't make a loop? I take a path like this. I make a path like this where I am going from A to B. I am going from where to where? I am going from A to B, right? So if I do like that, you will find that this is my appropriate point. Okay, let's check for you. So I am going from where to where? I am going from A to B. Therefore you will be writing potential at B minus potential at A, and the potential at A is equal to 0. Okay, this is equal to what? Okay, so you are going from the negative to the positive terminal. So plus 1. Now you are going across the 2 ohm resistor. Okay, and what about the direction of the current? Well, 2 ampere current is going here like this. 1 ampere current is being depicted here. So if 2 ampere was incoming, 1 ampere is going here. So what is the remaining current? It's 1 ampere by Kirchhoff current law. So I'll find that I'm going against the direction of current, that is of 1 ampere. So plus 1 into 2. Now you are going from the positive to the negative terminal of the battery. Therefore minus 2 again here. Okay, this is equal to VB minus VA. So VB is equal to how much? It's 1 plus 2 minus 2, that is equal to 1 volt. Hence the correct answer to this question is 1 volt. You won't believe that the questions were given in the form of options minus 2, plus 1, minus 1 and plus 2. So if the symbol is also being asked here, I can find that this is plus 1 volt. Okay, does that make a sense? So what is the learning that you should take from this question? Well, I will understand from this question that if somehow that there is not given to me the value of the resistances in between of the part, and I just know how to solve using the loop law. Instead of taking the loop, okay, I have to take some other pathway, okay, which is more easier and more shorter than the previous one. Okay, so I hope you understood this. Okay, perfect. So let me take another one. Okay, after this question you will get a bumper question, so be ready for that as well. This question asks that see the electrical circuit shown in the figure, which of the following equation is a correct equation for it, which is a correct equation for it. Okay, so it's given like this. Okay, so this is I1, this is I2, this is your R2, this is R1, this is E1, this is E2, and this is a capital R. Okay, so all the values are present to you. Okay, you have to find that which of the following equations are right. E1 minus I1 plus I2 upon R minus I1 R1 is equal to 0. Okay, second, E2 minus I2 R2 minus E1 minus I1 R1 is equal to 0. The third, minus E2 minus I1 plus I2 R plus I1 to R is equal to 0. Or the last one, E1 minus I1 plus I2 into R plus I1 R1 is equal to 0. Okay, the question is there in front of you, the circuit diagram is in front of you. Hold your pen and start the question, guys. Start it. Okay, I hope at least you have given a try. So let's begin of how to solve this question. Basically, I can see that this is the pathway of the current given. So can I say that the final current that is going through the external resistor is I1 plus I2? Well, that is very obvious. Now, let us do this. Can I say here that I can make loops? Definitely you will have to make. So let us say that this is my loop number 1 and this is my loop number 2. Talking about the loop number 1, let's write the equation here. So I am going in this way, like this. Perfect. Okay. So I can go from the, I am going from the lower terminal to the higher terminal, therefore plus E1. Okay. Then you are going to the second resistor in the same direction as that of the current, I1 plus I2. So minus I1 plus I2 minus of I1 plus I2 into the resistance R. And when you get down, you can write here that you are going here like this is my I1, this will be okay. So minus of I1 into R1, this is equal to 0. Does any of the option matches with it? Well, that's option number 1. Therefore correct answer is option number A. But still, let us do it for second one. Okay, and after this I will teach you one more thing. Okay, so let us talk about the second loop. Second loop is something like this. I am going here like this. Okay, so let's begin with here itself. I am going in the same direction as that of the current I2 for R1. So minus of I2 R2. Okay, then you are here going from the positive terminal of the cell to the negative terminal. So minus E1. Then you are going in opposite direction to the current of R1. Therefore plus I1 R1. Okay, and then you are back going from the positive to the negative terminal. Therefore minus of E2 is equal to 0. I hope that makes sense. Is any option matching with the same? Check it. No, none of the option matches here. Therefore loop number 2 is therefore the correct answer is definitely the first one. But what I want you to learn is that can I make some other loop in the same question? Well, you will require to know that. So let me show you that in the same question you can make one more loop. So
the problem is not effort. It's lack of personal attention. With one-to-one mentoring, every doubt is addressed, every concept is applied, and real improvement begins.